All right, now let's think about what just happened. So, the probability of Bob's coin landing heads up, we said was going to be 50% because Bob was flipping a normal coin. Well, when Bob flipped his coin 5 times, it landed heads up 60% of the time. When he flipped 10 times, it landed heads up 40% of the time. When he flipped 20 times, it landed heads up 45% of the time. When he flipped his coin 100 times, it landed heads up 47% of the time. And then when he flipped his coin 999 times, it landed heads up 48.55% of the time. So when Bob just did a few flips, landed heads up 60% of the time, close to 50%, but there was a big difference. Same thing when he flipped his coin 10 times, it landed heads up 40% of the time. That's close to 50%, but there's a big difference. When he flipped his coin 20 times, he got heads up 45% of the time. Close to 50%, but large difference. By the time we got to flipping his coin 100 times, we got a pretty good estimate of 50%. We got 47%. And when he flipped the coin 999 times, we got a pretty darn good estimate of the probability of Bob of his coin landing heads up. We got 48.55%. So we see that as Bob did more and more flips, the percentage of the time that he got heads got closer and closer to 50%, which is the actual probability of him getting heads, because we said Bob was flipping a normal quarter. So let A represent the event Bob's coin lands heads up when flipped. We see that the probability of A can be estimated by the following formula. Here's what we did before. We found the number of times A occurred. In other words, the number of desired outcomes or successes, or in other words, the number of heads. So we took the number of heads and we divided by the number of times the procedure was repeated. So in other words, we took the number of heads, we divided by the number of flips. That's how we were estimating the probability of Bob's coin flipping heads up. So this is called the relative frequency approximation for the probability of event A. So that's what we were doing. We were finding relative frequency approximations for the probability of Bob's coin landing heads up. Now, remember, the words relative frequency pretty much mean percent. So if you ever hear the words relative frequency, think percent, the percent of times something happens. So we saw that as the number of coin flips increased, or in other words, as the number of times the procedure was repeated, Bob got a better and better estimate for the probability of his coin landing heads up. Now, this idea describes the law of large numbers, which says as a procedure is repeated again and again, the relative frequency probability of an event tends to approach the actual probability of the event. So in other words, as Bob flips his coin more and more often, his coin is going to get closer and closer to landing heads up 50% of the time. Now, all games at a casino are designed so that the probability of losing money is greater than the probability of winning money. If Bob gambles at a casino, a friend might warn him, the house always wins in the long run. So this means that although Bob might get lucky and win some money at the casino for a while, as Bob plays a game more and more, the percent of times that he loses the game approaches the actual probability of him losing the game. So therefore, over time, Bob will lose more often than he wins, or I should say he will lose more money than he wins. So the idea that the house always wins describes the law of large numbers. So yeah, if Bob plays a casino game over and over and over again, he might win for a while. But over time, if the game is designed so that Bob only wins 40% of the time or only wins money 40% of the time, over time, Bob is only going to win about 40% of the time. So in this way, the casino is designed to make money. Over time, everybody will lose money at a casino playing games of chance.